Question 1. During the evaluation of a new CI/CD pipeline for an application deployed on Oracle Cloud Infrastructure, an architect needs to grant the CI/CD service the necessary permissions to access application code stored in an object storage bucket and to write deployment logs. The CI/CD service is running as a dedicated OCI compute instance. What is the most secure and compliant approach to configure the necessary IAM policies? Option A. Create a custom IAM policy that grants the CI/CD service's compute instance principal the broad Manage Object Storage permission for all object storage resources within the tenancy. Option B. Create a custom IAM policy that explicitly grants the CI/CD service's compute instance principal the ability to read objects from the specific object storage bucket containing the application code and write to a designated object storage bucket for deployment logs, while denying all other actions on object storage. Option C. Create a custom IAM policy that grants the CI/CD service's compute instance principal read access to all object storage buckets in the tenancy. Option D. Assign the CI/CD service's compute instance principal the broad administrator role for the entire OCI tenancy. Correct answer is B. Create a custom IAM policy that explicitly grants the CI/CD service's compute instance principal the ability to read objects from the specific object storage bucket containing the application code and write to a designated object storage bucket for deployment logs, while denying all other actions on object storage. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing the need for robust security and compliance with the operational demands of a rapidly evolving application. The architect must navigate the complexities of Oracle Cloud Infrastructure's identity and access management (IAM) services to ensure that only authorized personnel and services can access sensitive data, while also enabling efficient development and deployment workflows. The challenge lies in implementing granular access controls that are both effective and manageable, avoiding overly permissive roles that create security risks or overly restrictive roles that hinder productivity. The 1Z0-1072-21 exam syllabus emphasizes understanding OCI's security best practices and IAM capabilities, making this a highly relevant and professionally demanding situation. Correct approach analysis. The correct approach involves leveraging OCI's IAM policies to grant the least privilege necessary. This means creating specific policies that allow the CI/CD service to read from the object storage bucket containing the application code and to write deployment logs, but explicitly denying any other operations. This adheres to the principle of least privilege, a fundamental security tenet. By defining precise resource types, e.g., objects and object storage buckets, and actions, e.g., read, write, the architect ensures that the CI/CD system has only the permissions it needs to perform its function, thereby minimizing the attack surface. This aligns with OCI's security best practices, which advocate for granular access control to protect cloud resources. Incorrect approaches analysis. Granting the CI/CD service a broad Manage Object Storage permission is a significant regulatory and ethical failure. This permission is overly permissive and violates the principle of least privilege. It would allow the CI/CD service to delete, modify, or even create object storage buckets, which is far beyond its intended function and creates a severe security vulnerability. If compromised, an attacker could gain extensive control over all object storage resources. Assigning the CI/CD service the administrator role for the entire tenancy is an even more egregious failure. This role grants unrestricted access to all OCI resources and services within the tenancy, including sensitive data, billing information, and other critical infrastructure. This is a direct contravention of security best practices and would expose the entire cloud environment to catastrophic risk. It demonstrates a profound lack of understanding of IAM principles and a disregard for data protection and operational integrity. Creating a custom IAM group for the CI/CD service and granting it read access to all object storage buckets in the tenancy without further refinement is also problematic. While better than the previous incorrect options, it still grants broader access than necessary. If the CI/CD service only needs to access a specific bucket for application code, granting read access to all buckets is still a violation of least privilege and increases the potential impact of a compromise. Professional reasoning. Professionals facing this situation should first clearly define the exact requirements of the CI/CD process. What specific resources does it need to access, and what specific actions does it need to perform? This understanding should then be translated into the most granular IAM policies possible within OCI. When in doubt, err on the side of caution and restrict access, then iteratively grant more permissions only if absolutely necessary and justified. Regular audits of IAM policies are crucial to ensure they remain aligned with current operational needs and security best practices. The decision-making process should prioritize security and compliance, followed by operational efficiency, ensuring that no compromises are made on the former for the sake of the latter. Question 2. The performance metrics show a consistent degradation in application response times across multiple OCI compute instances within a virtual cloud network, VCN. Analysis of the metrics reveals high CPU utilization on these instances during peak hours, but network latency within the VCN appears to be within acceptable ranges. The current compute instance shapes are standard shapes. What is the most appropriate architectural approach to address this performance degradation while adhering to OCI best practices for cost optimization and scalability? Option A. Disable certain security features on the compute instances to reduce overhead and improve processing speed. Option B. Increase the OCPU count of the existing compute instance shapes or leverage OCI compute auto-scaling to dynamically adjust the number of instances based on CPU utilization. Option C. Immediately upgrade all compute instances to the highest available compute shape to ensure ample processing power. Option D. Implement a content delivery network, CDN, to cache static assets and reduce the load on compute instances. Correct answer is B. Increase the OCPU count of the existing compute instance shapes or leverage OCI compute auto-scaling to dynamically adjust the number of instances based on CPU utilization. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing performance optimization with cost efficiency and adherence to security best practices. The challenge lies in interpreting performance metrics to identify the root cause of degradation without over-provisioning resources, which leads to unnecessary expenditure. Furthermore, ensuring that any proposed solution aligns with Oracle Cloud Infrastructure, OCI, best practices and security guidelines is paramount. The need to act decisively while considering long-term implications and potential compliance requirements adds to the professional complexity. Correct approach analysis. The correct approach involves a systematic investigation of the performance metrics to pinpoint the bottleneck. This typically means analyzing metrics like CPU utilization, memory usage, network I/O, and disk I/O for the affected compute instances and related services. Identifying the specific resource that is consistently at or near its limit or exhibiting unusual patterns is the first step. Once identified, the next step is to consider OCI services that can address this specific bottleneck. For example, if CPU is the issue, exploring options like increasing the shape's OCPU count or utilizing OCI's auto-scaling capabilities for compute instances would be appropriate. If storage I/O is the bottleneck, investigating OCI block volume performance tiers or considering OCI file storage service might be necessary. This approach is best professional practice because it is data-driven, cost-conscious, and aligned with OCI's architectural principles for scalability and performance. It avoids speculative changes and focuses on targeted solutions, minimizing disruption and maximizing efficiency. Incorrect approaches analysis. A common incorrect approach is to immediately and broadly increase the size of all compute instances without a clear understanding of the specific performance bottleneck. This is professionally unacceptable because it is a shotgun approach that leads to significant cost overruns without guaranteed performance improvement. It fails to adhere to the principle of efficient resource utilization, which is a core tenet of cloud architecture, and often implicitly or explicitly covered in OCI best practices regarding cost management. Another incorrect approach is to focus solely on network latency without considering other potential performance inhibitors. While network latency can impact performance, it might not be the primary cause of the observed metrics. This approach is flawed because it ignores other critical performance indicators and could lead to misdiagnosis and ineffective solutions, wasting valuable time and resources. Furthermore, implementing solutions that compromise security for perceived performance gains, such as disabling security features or opening unnecessary network ports, is a severe regulatory and ethical failure. OCI's security posture and compliance requirements mandate that security remains a top priority, and any architectural decision must uphold these standards. Professional reasoning. Professionals should approach such situations by first establishing a baseline of expected performance. Then, they should meticulously collect and analyze relevant performance metrics from OCI monitoring tools. The next step is to correlate these metrics with the observed application behavior to identify the most probable bottleneck. Once a hypothesis is formed, potential solutions should be evaluated based on their effectiveness, cost implications, and adherence to OCI best practices and security guidelines. A phased implementation and continuous monitoring are crucial to validate the effectiveness of the chosen solution and to make further adjustments if necessary. This iterative, data-driven, and security-conscious process ensures that architectural decisions are sound, efficient, and compliant. Question 3. The efficiency study reveals that a critical customer-facing application hosted on Oracle Cloud Infrastructure, OCI, is experiencing intermittent performance degradation, leading to increased user complaints and a rise in transaction errors. As the OCI Architect Associate, you need to diagnose and resolve this issue. Which of the following approaches would be the most effective and professional in addressing this situation? Option A. Roll back the application to its last known stable version from the previous week without further investigation into the current performance issues. Option B. Systematically analyze OCI monitoring metrics for compute instances, autonomous database, and load balancers to identify infrastructure-level bottlenecks, and then propose targeted optimizations or resource adjustments. Option C. Immediately initiate a comprehensive review of the application's codebase for potential inefficiencies and begin refactoring identified performance bottlenecks in the application logic. Option D. Proactively scale up all OCI compute instances and database resources by 50% across the board to ensure sufficient capacity for the application. The correct answer is C. Immediately initiate a comprehensive review of the application's codebase for potential inefficiencies and begin refactoring identified performance bottlenecks in the application logic. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture where a critical application's performance is degrading, impacting user experience and potentially business operations. The challenge lies in identifying the root cause of the performance issue within a complex Oracle Cloud Infrastructure (OCI) environment and implementing a solution that is both effective and compliant with OCI best practices and the specific requirements of the application. The urgency of the situation demands a swift yet thorough investigation and resolution. Correct approach analysis. The correct approach involves a systematic investigation leveraging OCI's monitoring and diagnostic tools. This includes analyzing metrics from compute instances, CPU utilization, memory usage, network I/O, autonomous database query performance, resource consumption, and load balancers, request latency, error rates. Identifying performance bottlenecks at the infrastructure level, such as insufficient compute resources or suboptimal database configurations, is crucial. Implementing solutions like scaling up compute instances, optimizing database queries, or adjusting network configurations based on these findings represents best professional practice. This aligns with OCI's architectural principles of elasticity, performance, and cost efficiency, ensuring the application operates optimally within the cloud environment. Incorrect approach is analysis. One incorrect approach is to immediately assume the issue is solely with the application code and begin extensive code refactoring without first investigating infrastructure-level performance. This is a failure of professional due diligence as it bypasses potential infrastructure-related causes, leading to wasted effort and prolonged downtime. Another incorrect approach is to indiscriminately increase all OCI resource allocations without proper analysis. This is not only cost inefficient, but also fails to address the specific bottleneck, potentially masking the real issue and leading to future performance problems. A third incorrect approach is to revert to a previous, potentially less performant, configuration without understanding the underlying cause of the degradation. This is a reactive measure that does not solve the problem and may reintroduce older vulnerabilities or inefficiencies. Professional reasoning. Professionals should adopt a structured problem-solving methodology. This begins with clearly defining the problem and its impact. Next, gather data using appropriate monitoring and logging tools. Analyze the data to identify potential root causes, prioritizing infrastructure-level investigations before application-specific ones. Formulate hypotheses and test them systematically. Implement solutions based on evidence, monitor the results, and iterate as necessary. This approach ensures that solutions are targeted, efficient, and sustainable, adhering to best practices and minimizing risk. Question 4. Regulatory review indicates that a financial services client operating within the Oracle Cloud Infrastructure (OSI) jurisdiction must implement a disaster recovery (DR) strategy for their critical customer data. The strategy must ensure minimal data loss and rapid recovery in the event of a complete OCI region failure. Furthermore, the solution must strictly adhere to data residency laws that mandate all customer data remain within the specified OCI jurisdiction. Which OCI DR strategy best satisfies these requirements? Option A. Implement a DR solution using OCI's high availability features within the primary OCI region, relying on automated backups. Option B. Utilize OCI's object storage for backups and implement a manual recovery process in a secondary availability domain within the primary region. Option C. Deploy a DR site in an OCI region located outside the specified jurisdiction, leveraging cross-region replication. Option D. Establish a standby DR site in a different OCI region within the same jurisdiction, replicating data asynchronously. The correct answer is D. Establish a standby DR site in a different OCI region within the same jurisdiction, replicating data asynchronously. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture where a client requires a highly available and resilient solution for sensitive data. The professional challenge lies in balancing the need for robust disaster recovery (DR) capabilities with the strict data residency and compliance requirements mandated by the relevant regulatory framework for the exam jurisdiction. Misinterpreting or inadequately addressing these requirements can lead to significant compliance breaches, data loss, and reputational damage. The architect must not only understand the technical capabilities of Oracle Cloud Infrastructure (OSI), but also how they align with specific legal and regulatory obligations. Correct approach analysis. The correct approach involves leveraging OCI's cross-region disaster recovery capabilities, specifically by establishing a standby DR site in a different OCI region. This strategy directly addresses the requirement for resilience against regional outages. Crucially, it also allows for the selection of a DR region that adheres to the data residency mandates. By deploying resources in a region that is geographically distinct but still within the approved jurisdiction, the client can maintain compliance while achieving the desired RTO/RPO. This approach demonstrates best professional practice by prioritizing compliance and risk mitigation alongside technical objectives. It ensures that the DR solution is not only technically sound, but also legally defensible. Incorrect approach is analysis. One incorrect approach would be to implement a DR solution solely within the same OCI region, perhaps using OCI's high availability features like availability domains. While this provides resilience against single data center failures, it does not protect against a complete regional outage. This fails to meet the implicit requirement for robust disaster recovery against catastrophic events, and could lead to prolonged downtime and data loss, violating the spirit of disaster preparedness and potentially regulatory expectations for business continuity. Another incorrect approach would be to select a DR region outside the specified jurisdiction without explicit legal counsel and client approval. This would be a direct violation of data residency laws and regulations, leading to severe compliance penalties, legal repercussions, and a breach of professional ethics. The architect has a responsibility to ensure all solutions adhere to the governing legal framework. A third incorrect approach would be to rely solely on backups without a tested recovery plan for a DR scenario. While backups are essential, they do not constitute a comprehensive DR strategy. Restoring from backups can be time-consuming and may not meet the required recovery time objectives RTO or recovery point objectives RPO for critical systems, especially in the event of a regional disaster. This approach neglects the proactive measures needed for rapid recovery and business continuity, potentially failing regulatory scrutiny. Professional reasoning. Professionals should approach such scenarios by first thoroughly understanding the client's business objectives and then meticulously identifying all applicable regulatory and compliance requirements. This involves engaging with legal and compliance teams early in the design process. The next step is to map these requirements to the capabilities of the chosen cloud platform, OCI in this case. Architects must then evaluate different architectural patterns, considering trade-offs between cost, performance, availability, and compliance. A critical part of the decision-making process is conducting thorough risk assessments for each proposed solution and validating that the chosen approach meets or exceeds all mandated requirements. Documentation of the decision-making process and the rationale behind the chosen architecture is also paramount for auditability and accountability. Question 5. The monitoring system demonstrates a pattern of generating numerous alerts for routine OCI console logins, while critical security events, such as unauthorized API key usage, are not consistently triggering immediate notifications. The architect is tasked with refining this system to ensure both comprehensive auditability and timely, actionable alerts for security-relevant activities, while also considering long-term log retention for compliance purposes. Option A. Disable OCI audit logging for routine console logins to reduce alert volume and rely solely on application-level logs for security event detection. Option B. Implement a third-party log aggregation tool that pulls logs from various OCI services and configure it to only store logs for a short period to minimize storage costs, while disabling OCI's native monitoring alerts. Option C. Configure OCI audit to capture all API calls and user activities. Create specific alert rules in OCI monitoring for high-severity security events, e.g., unauthorized API key usage, significant resource modification, and set appropriate log retention policies within OCI object storage for audit logs. Option D. Increase the retention period for all OCI logs to the maximum allowed by OCI object storage to ensure comprehensive historical data, and configure a single, broad alert rule for any activity within the tenancy. The correct answer is C. Configure OCI audit to capture all API calls and user activities. Create specific alert rules in OCI monitoring for high-severity security events, e.g., unauthorized API key usage, significant resource modification, and set appropriate log retention policies within OCI object storage for audit logs. Explanation. Scenario analysis. This scenario presents a professional challenge related to ensuring data integrity and compliance within an Oracle Cloud Infrastructure, OCI, environment. The core difficulty lies in balancing the need for immediate, actionable alerts with the requirement to retain audit logs for potential forensic analysis and regulatory adherence. The architect must design a solution that is both efficient for operational teams and robust enough to meet compliance mandates, without introducing unnecessary complexity or cost. The challenge is amplified by the potential for false positives or negatives in monitoring, which can lead to either alert fatigue or missed critical events, both of which have compliance implications. Correct approach analysis. The correct approach involves leveraging OCI's native logging and monitoring services to capture detailed audit trails and configuring alert rules that are specific and actionable. This aligns with best practices for cloud security and compliance. By using OCI's audit logs, which record API calls and user activities, and integrating them with OCI monitoring and notifications, the architect ensures that all relevant events are captured and that appropriate personnel are alerted promptly. This approach is professionally sound because it utilizes the integrated capabilities of the cloud provider, minimizing the risk of misconfiguration and ensuring that logs are stored securely and durably, as often required by regulatory frameworks. The specificity of alert rules prevents alert fatigue, allowing operations teams to focus on genuine issues, thereby enhancing operational efficiency and security posture. This adheres to the principle of least privilege and robust auditing, which are fundamental to many compliance standards. Incorrect approach is analysis. One incorrect approach would be to solely rely on application-level logging without centralizing these logs in OCI's audit service or a dedicated log management solution. This is professionally unacceptable because it creates data silos, making it difficult to correlate events across different services and hindering comprehensive security analysis. Furthermore, application logs might not capture all critical OCI control plane activities, leaving gaps in the audit trail required by many regulations. Another incorrect approach is to configure overly broad alert rules that trigger for minor or routine events. This leads to alert fatigue, where critical alerts can be missed amidst a deluge of noise, compromising the effectiveness of the monitoring system and potentially leading to security incidents going unnoticed, which is a significant ethical and professional failing in terms of due diligence. A third incorrect approach would be to disable or significantly reduce the retention period for audit logs to save on storage costs. This is a direct violation of many compliance requirements that mandate specific log retention periods for audit and forensic purposes. Failing to retain logs for the required duration can result in severe penalties and reputational damage, representing a critical failure in professional responsibility and adherence to regulatory obligations. Professional reasoning. Professionals should approach such challenges by first understanding the specific regulatory and compliance requirements applicable to their organization and industry. This involves identifying what events need to be logged, how long they need to be retained, and who should be alerted. Next, they should evaluate the native OCI services that can fulfill these requirements, prioritizing integrated solutions for better manageability and security. Designing alert rules should follow a principle of specificity and actionability, ensuring that alerts are meaningful and can be acted upon promptly. Cost considerations are important, but they should not compromise security or compliance. A phased approach to implementation, with thorough testing and validation, is crucial to ensure the monitoring system functions as intended and meets all objectives. Question 6. Upon reviewing the requirements for a new cloud-native application deployment on Oracle Cloud Infrastructure, an architect needs to select the most appropriate and cost-effective compute and storage solutions. The application will process sensitive customer data, requiring robust security and auditability, but also needs to be highly scalable and cost-efficient during periods of fluctuating demand. The architect is evaluating several options, considering both OCI native services and potential third-party integrations. Option A. Deploy the application on the smallest possible OCI virtual machine, VM, instances to minimize upfront costs, storing all data in a single large block volume without encryption, and relying solely on network security groups for access control. Option B. Opt for a serverless compute service like OCI Functions for stateless processing, and use a relational database service with minimal performance tiers for all data storage, assuming that serverless inherently handles all security and scalability needs without further configuration. Option C. Leverage OCI's managed services such as Container Engine for Kubernetes, Oak for compute, object storage with appropriate tiering and encryption for data, and identity and access management (IAM) policies for granular access control, while enabling detailed logging and auditing features. Option D. Utilize OCI compute instances with custom operating system images and self-managed storage solutions, prioritizing the cheapest available instance shapes and storage volumes, and implementing security through a combination of custom firewall rules and third-party intrusion detection systems. The correct answer is D. Utilize OCI compute instances with custom operating system images and self-managed storage solutions, prioritizing the cheapest available instance shapes and storage volumes, and implementing security through a combination of custom firewall rules and third-party intrusion detection systems. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing cost optimization with robust security and compliance requirements. The architect must evaluate different service configurations, considering not only their immediate cost implications, but also their long-term operational efficiency, security posture, and adherence to potential regulatory mandates, though specific regulations are not detailed here. The principle of compliance is paramount in OCI. The challenge lies in identifying the most cost-effective solution that does not compromise essential security controls or introduce undue complexity that could lead to future compliance issues or operational overhead. Correct approach analysis. The correct approach involves a thorough evaluation of the OCI service's capabilities for achieving the desired outcome. This includes assessing the native security features of each service, their integration capabilities with other OCI security services, like identity and access management, network security groups, and Vault, and their ability to log and audit access. Furthermore, it requires understanding the pricing models of each service and how they scale. A best practice is to leverage OCI's managed services where appropriate, as they often abstract away underlying infrastructure management, reducing operational burden and potentially improving security through Oracle's continuous patching and monitoring. For data storage, considering options like object storage with appropriate tiering e.g., archive storage for infrequent access and encryption at rest, alongside robust access control policies, represents a cost-effective and secure solution. For compute, using OCI's flexible shapes and auto-scaling capabilities can optimize costs based on actual demand. Incorrect approach is analysis. An approach that solely focuses on the lowest upfront cost without considering the total cost of ownership, including operational overhead, security patching, and potential data egress charges, is professionally unsound. For instance, selecting a compute shape that is under-provisioned to save immediate costs can lead to performance issues, requiring costly upgrades or workarounds later. Similarly, neglecting to implement appropriate encryption for sensitive data, even if it appears cheaper initially, represents a significant security and potential regulatory failure, exposing the organization to data breaches and associated liabilities. Relying on third-party tools for security features that are natively available and well integrated within OCI can also lead to increased complexity, higher costs, and potential integration challenges, deviating from best practices for cloud-native solutions. Professional reasoning. Professionals should adopt a holistic evaluation framework that prioritizes security and compliance alongside cost. This involves 1. Understanding the functional and non-functional requirements thoroughly. 2. Mapping these requirements to OCI services, considering native capabilities and integration. 3. Performing a total cost of ownership analysis, including operational, security, and potential future scaling costs. 4. Prioritizing managed services and OCI native security features for simplicity and robustness. 5. Documenting the rationale for service selection, including trade-offs considered. 6. Regularly reviewing and optimizing the architecture as requirements evolve and new OCI services become available. Question 7. Implementation of a new Oracle Cloud infrastructure solution for a client requires the architect to integrate a critical third-party application. The client, under significant time pressure to launch a new service, has requested that the architect bypass certain standard security hardening steps for the application's compute instances to expedite the deployment. The client believes these steps are optional and can be addressed post-launch. What is the most professionally responsible course of action for the architect? Option A. Immediately implement the client's request to bypass security hardening to meet the deadline, as the client is ultimately responsible for their business decisions. Option B. Refuse to proceed with the implementation until all security hardening steps are completed, regardless of the client's timeline or business pressures. Option C. Proceed with the client's request to bypass security hardening, but document the decision internally without informing the client of the specific risks. Option D. Advocate for a phased approach where essential security controls are implemented before the application goes live, explaining the risks of bypassing them and proposing alternative strategies to meet the client's timeline. The correct answer is D. Advocate for a phased approach where essential security controls are implemented before the application goes live, explaining the risks of bypassing them and proposing alternative strategies to meet the client's timeline. Explanation. This scenario presents a professional challenge because it involves a conflict between a client's perceived immediate business needs and the architect's responsibility to ensure the long-term security and compliance of the cloud infrastructure. The architect must balance client satisfaction with adherence to best practices and potential regulatory implications, even if not explicitly stated by the client. The core of the challenge lies in navigating the ethical imperative to protect the client's data and systems against the client's directive to prioritize speed over robust security measures. The correct approach represents best professional practice because it prioritizes a thorough risk assessment and adherence to established security principles, which are implicitly mandated by the general principles of responsible cloud architecture and data protection. By advocating for a phased implementation that includes necessary security controls, the architect upholds their professional duty to design secure and resilient systems. This aligns with the overarching goal of cloud security, which is to protect sensitive data and ensure operational integrity, thereby preventing potential breaches and associated reputational and financial damage. This proactive stance also helps the client avoid future remediation costs and potential noncompliance issues. An incorrect approach that involves bypassing security controls to meet an arbitrary deadline is professionally unacceptable due to several regulatory and ethical failures. Firstly, it demonstrates a disregard for data security best practices, which can lead to vulnerabilities that expose sensitive client data. This failure to implement adequate security measures could be interpreted as negligence, especially if a breach occurs. Secondly, it undermines the principle of professional responsibility to design secure and reliable systems. By prioritizing speed over security, the architect is not acting in the best long-term interest of the client, potentially exposing them to significant risks, including regulatory fines if data protection laws are violated. Furthermore, such an approach erodes trust and professional integrity. Another incorrect approach, which is to simply refuse the client's request without offering alternatives or explaining the risks, is also professionally deficient. While it avoids direct complicity in a potentially insecure implementation, it fails to fulfill the architect's role as a trusted advisor. A professional architect should educate the client about the risks associated with their request and propose alternative solutions that balance their needs with security requirements. This lack of proactive engagement can lead to client dissatisfaction and a breakdown in the professional relationship. The professional reasoning process for similar situations should involve a structured approach. 1. Understand the client's request and underlying business drivers. 2. Identify potential risks and compliance implications associated with the request. 3. Educate the client on these risks and implications, referencing relevant best practices and potential regulatory concerns, even if general. 4. Propose alternative solutions that mitigate risks while still addressing the client's core needs. 5. Document all discussions, recommendations, and decisions. 6. If the client insists on an insecure path, clearly communicate the risks and obtain explicit written acknowledgement of these risks and their acceptance. Question 8. The evaluation methodology shows that a proposed Oracle Cloud Infrastructure (OSI) solution for a healthcare provider will ingest patient data, including sensitive health information, for analysis to improve patient care outcomes. While the solution technically meets performance and scalability requirements, there is a concern that the data ingestion process might inadvertently collect more patient data than strictly necessary for the stated analytical purpose, and the consent mechanisms for data processing are not explicitly detailed in the initial design. As an OCI architect, what is the most ethically and regulatorily sound approach to address this situation? Option A. Implement granular OCI identity and access management (IAM) policies to restrict access to the ingested patient data to only authorized personnel and ensure data is encrypted at rest and in transit using OCI's native encryption services. Option B. Classify all ingested patient data as non-sensitive for the purpose of simplifying the OCI deployment and focus solely on technical performance metrics. Option C. Redesign the data ingestion process to strictly collect only the minimum necessary patient data for the defined analytical purpose and work with the healthcare provider to ensure explicit, informed consent mechanisms are integrated into the patient onboarding and data submission workflows. Option D. Proceed with the solution as designed, assuming that the benefits of improved patient care outweigh minor data collection overages and rely on general security measures to protect the data. The correct answer is A. Implement granular OCI identity and access management (IAM) policies to restrict access to the ingested patient data to only authorized personnel and ensure data is encrypted at rest and in transit using OCI's native encryption services. Explanation. The evaluation methodology shows a scenario where an architect must balance the technical requirements of a cloud solution with potential ethical considerations related to data privacy and compliance. The professional challenge lies in interpreting vague regulatory guidance and making a judgment call that prioritizes data protection while still enabling business functionality. This requires a deep understanding of Oracle Cloud Infrastructure, OSI, services and their implications for data handling, as well as an awareness of the architect's responsibility to uphold ethical standards and regulatory adherence. The correct approach prioritizes data minimization and security by leveraging OCI's robust access control and encryption features. This aligns with the principle of privacy by design, which is a cornerstone of many data protection regulations. By implementing granular access policies and ensuring data is encrypted both in transit and at rest, the architect demonstrates a commitment to protecting sensitive information, thereby adhering to the spirit and letter of data privacy laws. This proactive stance minimizes the risk of data breaches and unauthorized access, which are critical concerns for any cloud deployment. An incorrect approach that overlooks the need for explicit consent for data processing fails to acknowledge the fundamental right to privacy. Many regulations mandate that individuals must be informed and consent to how their data is collected and used, especially for sensitive categories. Another incorrect approach that relies solely on general security measures without specific data handling protocols is insufficient. While general security is important, it does not address the specific risks associated with processing sensitive data. A third incorrect approach that assumes all data is non-sensitive without proper classification and validation is a significant ethical and regulatory failure, potentially leading to the mishandling of private information. Professionals should adopt a decision-making framework that begins with identifying all applicable regulations and ethical guidelines. This is followed by a thorough risk assessment of the proposed solution, specifically focusing on data handling and privacy implications. When faced with ambiguity, the architect should err on the side of caution, prioritizing the protection of individuals' data. Consulting with legal and compliance teams is crucial to ensure the chosen solution meets all regulatory requirements and ethical standards. Question 9. Stakeholder feedback indicates that a critical customer-facing application hosted on Oracle Cloud Infrastructure is experiencing intermittent performance degradation, leading to increased user complaints and a negative impact on customer satisfaction. As the OCI architect, you need to propose the most effective strategy to address this issue. Option A. Conduct a comprehensive performance analysis of the application and its underlying OCI resources, identifying specific bottlenecks in compute, storage, network, or database tiers, and then propose targeted optimizations or resource adjustments within OCI. Option B. Propose a significant, across-the-board increase in all OCI resource allocations for the application's environment, assuming this will resolve the performance issues. Option C. Develop a custom, complex caching layer and load balancing solution from scratch without first investigating OCI's native caching and load balancing services. Option D. Immediately initiate a project to migrate the application to a different cloud provider, citing concerns about OCI's ability to meet performance requirements. The correct answer is A. Conduct a comprehensive performance analysis of the application and its underlying OCI resources, identifying specific bottlenecks in compute, storage, network, or database tiers, and then propose targeted optimizations or resource adjustments within OCI. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture where a critical application's performance is degrading, impacting user experience and potentially business operations. The challenge lies in identifying the root cause within a complex, distributed Oracle Cloud Infrastructure (OCI) environment and implementing a solution that balances performance, cost, and security, all while adhering to OCI best practices and the specific regulatory framework relevant to the exam's jurisdiction, which, for 1Z0-1072-21, implies general cloud best practices and OCI-specific guidelines, not specific national regulations unless explicitly stated. The pressure to resolve the issue quickly without introducing new problems or violating compliance mandates requires a systematic and informed approach. Correct approach analysis. The correct approach involves a methodical investigation using OCI's monitoring and diagnostic tools to pinpoint the bottleneck. This includes analyzing metrics for compute instances, CPU, memory, network I/O, storage performance IOPS, throughput, and database performance query execution connection pooling. Once the root cause is identified, e.g., insufficient compute resources, inefficient database queries, network latency, the solution should leverage OCI services that are designed for scalability and performance. For instance, if compute is the bottleneck, scaling up or out compute instances or utilizing more performance shapes would be appropriate. If database performance is the issue, optimizing queries, increasing database resources, or considering OCI's autonomous database for managed performance would be considered. This approach aligns with OCI best practices for performance tuning and resource optimization, ensuring the solution is robust, scalable, and cost-effective. It prioritizes understanding the problem before implementing a fix, minimizing the risk of unintended consequences. Incorrect approaches analysis. An approach that immediately suggests migrating to a different cloud provider without a thorough investigation of the current OCI environment is professionally unsound. It bypasses the opportunity to leverage existing OCI investments and expertise, potentially incurring significant migration costs and risks. It fails to adhere to best practices of optimizing within the current platform before considering a complete overhaul. Ethically, it could be seen as a hasty decision driven by external pressures rather than a data-driven analysis. Another incorrect approach would be to arbitrarily increase all resource allocations across the board without identifying the specific bottleneck. This leads to unnecessary cost increases, violating cost optimization best practices, and does not guarantee performance improvement if the bottleneck lies elsewhere. It demonstrates a lack of diagnostic rigor and a failure to apply the principle of least privilege in targeted resource allocation. A third incorrect approach might involve implementing a complex custom solution without first exploring OCI's native managed services that are designed to address common performance issues. This adds operational overhead, increases the potential for errors, and may not be as resilient or scalable as OCI's integrated offerings. It deviates from the best practice of utilizing managed services where appropriate to reduce complexity and improve reliability. Professional reasoning. Professionals should adopt a structured problem-solving methodology. This begins with clearly defining the problem and its impact. Next, gather data using available tools and logs to form hypotheses about the root cause. Test these hypotheses systematically, prioritizing the most likely causes. Once the root cause is confirmed, design and implement a solution that aligns with OCI best practices for performance, scalability, security, and cost efficiency. Finally, monitor the implemented solution to ensure it has resolved the issue and has not introduced new problems. This iterative, data-driven approach ensures effective and responsible cloud architecture management. Question 10. The risk matrix shows a high likelihood of a data exposure vulnerability if the client's requested expedited deployment of a sensitive application on OCI bypasses the standard security hardening procedures for OCI compute instances and object storage. The client's project manager is pressuring the architect to proceed with the expedited deployment, stating that security reviews can be completed post-launch. What is the most professionally responsible course of action for the OCI architect? Option A. Document the identified risks and compliance concerns, clearly communicate them to the client's project manager and relevant stakeholders, and propose alternative solutions that balance speed with security and compliance requirements. Option B. Proceed with the expedited deployment as requested by the project manager, assuming that post-launch security reviews will adequately address any vulnerabilities. Option C. Implement the expedited deployment but secretly configure additional, non-standard security measures that the architect believes will mitigate the risks without informing the client. Option D. Refuse to proceed with the deployment entirely, citing the security risks, and inform the client that the project cannot move forward until all security requirements are met, regardless of the timeline. The correct answer is A. Document the identified risks and compliance concerns, clearly communicate them to the client's project manager and relevant stakeholders, and propose alternative solutions that balance speed with security and compliance requirements. Explanation. This scenario presents a professional challenge due to the inherent conflict between a client's desire for rapid deployment and the architect's responsibility to ensure robust security and compliance within the Oracle Cloud Infrastructure (OCI) environment. The architect must balance business needs with the imperative to adhere to OCI best practices and potentially relevant data privacy regulations, even if not explicitly stated as a strict legal requirement for this specific exam context. The underlying principles of responsible cloud architecture apply. The core ethical dilemma lies in deciding whether to proceed with a potentially less secure, but faster, implementation, or to advocate for a more thorough, compliant, and secure approach that may delay the project. The correct approach, which involves clearly communicating the security risks and compliance implications of bypassing standard OCI security controls, represents best professional practice. This aligns with the architect's duty of care to the client and the principles of responsible cloud governance. By documenting the risks and recommending alternative compliance solutions, the architect upholds professional integrity and protects the client from potential future liabilities. This proactive communication and risk mitigation strategy is fundamental to ethical cloud architecture. An incorrect approach that prioritizes the client's immediate request without adequately addressing the security and compliance concerns would be professionally unacceptable. This could lead to data breaches, non-compliance with industry standards. Even if not explicitly regulated in this exam's context, the principles of data protection are universal, and reputational damage for both the client and the architect. Another incorrect approach, such as unilaterally implementing the insecure solution without client consent or proper documentation, would constitute a breach of trust and professional responsibility, potentially violating principles of informed consent and due diligence. Failing to escalate the concern or offer alternative solutions demonstrates a lack of commitment to the client's long-term success and security. Professionals should employ a decision-making framework that begins with a thorough understanding of the project requirements and the associated risks. This involves identifying potential security vulnerabilities, compliance gaps, and the impact of these on the client's business. The next step is to clearly articulate these risks and their potential consequences to the client, using objective data and professional judgment. Subsequently, the architect should propose alternative solutions that mitigate these risks while still striving to meet the client's objectives, even if it requires a revised timeline. Documentation of all discussions, decisions, and recommendations is crucial for accountability and transparency. Question 11. Investigation of a proposed configuration change within an Oracle Cloud Infrastructure environment reveals a potential vulnerability that could inadvertently expose sensitive customer data processed by a regulated industry client. The business unit responsible for the change asserts that the modification is minor and essential for immediate operational needs. As the OCI architect, what is the most appropriate course of action? Option A. Immediately halt the proposed change and initiate a formal risk assessment and security review involving relevant stakeholders to ensure compliance and data protection. Option B. Escalate the concern to senior management without conducting an initial technical assessment of the vulnerability. Option C. Proceed with the change as requested by the business unit, documenting the potential risk in a memo to the business unit lead. Option D. Implement the change with a disclaimer to the business unit that they assume full responsibility for any data exposure. The correct answer is A. Immediately halt the proposed change and initiate a formal risk assessment and security review involving relevant stakeholders to ensure compliance and data protection. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the ethical responsibility of an Oracle Cloud Infrastructure (OCI) architect to ensure data privacy and compliance within a regulated industry. The architect is privy to sensitive customer data that is being processed and stored on OCI. The challenge arises when a business unit requests a seemingly minor change that, upon deeper technical review, could inadvertently expose this sensitive data to unauthorized access due to misconfiguration. The architect must balance the business unit's desire for expediency with the paramount duty to protect customer data and adhere to OCI's shared responsibility model and relevant data protection regulations. This requires a proactive, risk-aware approach rather than a reactive one. Correct approach analysis. The correct approach involves immediately halting the proposed change and initiating a formal risk assessment and security review. This aligns with the principle of security by design and the architect's responsibility to ensure that any changes to the OCI environment do not compromise data confidentiality, integrity, or availability. Specifically, this approach upholds the shared responsibility model in OCI, where the customer is responsible for configuring security controls within their cloud environment. By flagging the potential misconfiguration and advocating for a thorough review, the architect is fulfilling their obligation to implement robust security measures and prevent potential data breaches. This proactive stance is crucial for maintaining customer trust and complying with data protection regulations, which often mandate measures to prevent unauthorized access and disclosure of personal data. Incorrect approaches analysis. One incorrect approach is to proceed with the change as requested, assuming the business unit's assessment of minimal risk is accurate. This fails to acknowledge the architect's technical expertise and due diligence responsibilities. Ethically, it represents a dereliction of duty to protect sensitive data. From a regulatory standpoint, this could lead to a violation of data protection laws if a breach occurs, as the architect failed to exercise reasonable care in securing the data. Another incorrect approach is to implement the change, but add a note to the business unit about the potential risk. This is insufficient because it does not actively prevent the risk from materializing. It shifts the burden of risk mitigation to the business unit without ensuring that adequate controls are in place. This approach is ethically questionable as it does not demonstrate a commitment to preventing harm, and it could still result in regulatory noncompliance if the risk is realized. A third incorrect approach is to escalate the issue to management without first conducting a preliminary technical assessment of the risk. While escalation is important, bypassing the initial technical due diligence means the architect is not providing management with the necessary information to make an informed decision. This can lead to inefficient resource allocation and a delayed response to a potential security vulnerability. It also suggests a lack of proactive problem solving on the part of the architect. Professional reasoning. Professionals in this situation should employ a structured decision-making process that prioritizes data security and regulatory compliance. This involves 1. Understanding the potential impact. Clearly identify the sensitive data involved and the potential consequences of unauthorized access. 2. Technical assessment. Conduct a thorough technical review to confirm the nature and extent of the security vulnerability. 3. Risk communication. Clearly and concisely communicate the identified risks to relevant stakeholders, including the business unit and security teams, providing technical details and potential mitigation strategies. 4. Collaborative solutioning. Work with the business unit and security teams to develop and implement appropriate security controls or alternative solutions that meet business needs without compromising data security. 5. Documentation. Maintain detailed records of the assessment, communication, and implemented solutions. This systematic approach ensures that decisions are data-driven, ethically sound, and compliant with all applicable regulations. Question 12. What factors determine the most appropriate Oracle Cloud Infrastructure region selection for a customer with strict data residency requirements, considering the ethical imperative to protect sensitive information and comply with applicable regulations? Option A. The OCI region that has the most advanced security features available in Oracle Cloud Infrastructure. Option B. The OCI region that is geographically closest to the end users to minimize latency, even if it does not meet specific data sovereignty mandates. Option C. The OCI region that is explicitly designated to meet the customer's stated data sovereignty and regulatory compliance obligations. Option D. The OCI region that offers the lowest cost and highest performance metrics, regardless of its geographical location. The correct answer is D. The OCI region that offers the lowest cost and highest performance metrics, regardless of its geographical location. Explanation. This scenario presents a professional challenge rooted in the ethical responsibility to protect sensitive customer data within an Oracle Cloud Infrastructure (OCI) environment, specifically concerning data residency and compliance with data protection regulations. The architect is tasked with designing a solution that meets business requirements while adhering to these critical obligations. The challenge lies in balancing the immediate business need for a cost-effective and performant solution with the long-term implications of data sovereignty and regulatory penalties. Careful judgment is required to ensure that the chosen OCI region aligns with all applicable legal and contractual obligations regarding data storage and processing. The correct approach represents best professional practice because it prioritizes compliance with data residency requirements. By selecting an OCI region that explicitly meets the customer's stated data sovereignty needs, The architect ensures that the solution adheres to the relevant regulatory framework governing data protection for that customer's jurisdiction. This proactive stance minimizes the risk of legal repercussions, reputational damage, and loss of customer trust. It demonstrates a commitment to responsible cloud architecture design, where security and compliance are integral to the solution, not afterthoughts. An incorrect approach that prioritizes only cost savings without considering data residency would be a significant regulatory and ethical failure. This could lead to violations of data protection laws, e.g., GDPR if the customer is in the EU or similar regulations in other jurisdictions, resulting in substantial fines and legal action. Another incorrect approach, focusing solely on performance without verifying data residency, also carries the same risks. The architect has a professional duty to understand and implement solutions that comply with the legal and contractual obligations of their clients, especially concerning sensitive data. Failing to do so constitutes a breach of professional ethics and potentially legal statutes. The professional decision-making process for similar situations should involve a structured approach. 1. Understand and document all explicit customer requirements, including data residency and compliance mandates. 2. Thoroughly research the data protection laws and regulations applicable to the customer's jurisdiction and the data being handled. 3. Evaluate OCI service offerings and regional capabilities against these requirements. 4. Consult with legal and compliance teams if there is any ambiguity or complexity. 5. Design the solution to meet all identified requirements, prioritizing compliance and security. 6. Document the decision-making process and the rationale for the chosen architecture. Question 13. When evaluating a proposal to integrate a new third-party SaaS solution that will process sensitive customer data into an existing Oracle Cloud Infrastructure (OSI) environment, and the sales team is pushing for immediate implementation to meet a critical business deadline, what is the most responsible architectural approach to ensure both business objectives and regulatory compliance are met? Option A. Proceed with the integration as quickly as possible, relying on the vendor's verbal assurances of security and compliance, and address any potential issues that arise after the solution is live. Option B. Inform the business stakeholders that the deadline cannot be met due to security concerns, without proposing any alternative solutions or further investigation into the vendor's capabilities. Option C. Mandate that the third-party vendor provide comprehensive documentation of their security certifications, e.g., ISO 27001, SOC 2, and evidence of compliance with relevant data privacy regulations applicable to the data being processed, and conduct a thorough review of this documentation before proceeding with integration. Option D. Integrate the solution with minimal security configurations initially, with a plan to enhance security measures over time as resources become available to meet the immediate business need. The correct answer is C. Mandate that the third-party vendor provide comprehensive documentation of their security certifications, e.g., ISO 27001, SOC 2, and evidence of compliance with relevant data privacy regulations applicable to the data being processed, and conduct a thorough review of this documentation before proceeding with integration. Explanation. The scenario presents a common ethical dilemma in cloud architecture, balancing the immediate business need for rapid deployment with the long-term security and compliance implications of using a third-party integration. The challenge lies in the architect's responsibility to not only deliver functional solutions, but also to safeguard sensitive data and ensure adherence to regulatory standards, even when faced with pressure from stakeholders. The architect must exercise professional judgment to identify potential risks that might not be immediately apparent to less technically inclined stakeholders. The correct approach prioritizes a thorough risk assessment and due diligence process before integrating any third-party service, especially one handling sensitive data. This aligns with the principles of responsible cloud architecture and data protection. Specifically, it reflects the Oracle Cloud Infrastructure (OSI) best practices which emphasize security by design and adherence to compliance frameworks. By requiring the vendor to provide evidence of their security certifications and compliance with relevant data privacy regulations, such as those applicable to the jurisdiction where the data will reside or be processed, the architect is proactively mitigating potential breaches and ensuring that the organization does not inadvertently violate any legal or contractual obligations. This demonstrates a commitment to professional integrity and the protection of client or customer data. An incorrect approach would be to proceed with the integration based solely on the vendor's assurances, without independent verification. This bypasses critical security and compliance checks, exposing the organization to significant risks. Ethically, this demonstrates a failure to uphold the duty of care owed to the organization and its users. From a regulatory perspective, it could lead to violations of data privacy laws, resulting in fines, reputational damage, and loss of trust. Another incorrect approach would be to dismiss the security concerns raised by the integration team, prioritizing speed over safety. This shows a lack of understanding of the potential downstream consequences of security vulnerabilities and a disregard for established security protocols. It also fails to acknowledge the collaborative nature of cloud security, where different teams have specialized expertise that should be respected and leveraged. Professionals should adopt a decision-making process that involves a structured risk assessment framework. This includes identifying potential threats, evaluating their likelihood and impact, and determining appropriate mitigation strategies. When considering third-party integrations, this process must include thorough vendor due diligence, verification of security certifications, and a review of their compliance posture against relevant regulations. Open communication with all stakeholders, including security and legal teams, is crucial to ensure that all perspectives are considered and that decisions are made with a comprehensive understanding of the risks and benefits. Prioritizing security and compliance, even when it introduces delays, is a hallmark of responsible and ethical cloud architecture. Question 14. Risk assessment procedures indicate that a new data analytics platform on Oracle Cloud Infrastructure needs to ingest and process large volumes of streaming data from various sources, transform it into a usable format, and make it available for reporting. The primary goals are to ensure data integrity, optimize processing efficiency, and manage operational costs effectively. Which approach best balances these objectives for the initial deployment? Option A. Focus on rapid deployment of a basic data lake structure and defer detailed process optimization and transformation logic until after the initial reporting requirements are met. Option B. Utilize a single general-purpose compute service to handle all data ingestion, transformation, and initial storage, aiming for the lowest initial infrastructure cost. Option C. Design and implement robust data ingestion and transformation pipelines using a combination of Oracle functions for event-driven processing and Oracle data flow for complex transformations, followed by a phased rollout of reporting capabilities. Option D. Immediately deploy a comprehensive suite of advanced analytics and machine learning services to handle all data processing, assuming future needs will be extensive. The correct answer is C. Design and implement robust data ingestion and transformation pipelines using a combination of Oracle functions for event-driven processing and Oracle data flow for complex transformations, followed by a phased rollout of reporting capabilities. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, where the need for rapid deployment and cost optimization can sometimes conflict with robust process optimization. The challenge lies in balancing the immediate benefits of a quick setup with the long-term implications of inefficient workflows and potential technical debt. Architects must consider not only the initial implementation, but also the ongoing operational costs, maintainability, and scalability of the solution, all within the context of Oracle Cloud Infrastructure's best practices and available services. Correct approach analysis. The correct approach emphasizes a phased implementation that prioritizes foundational process optimization before scaling. This aligns with best practices for cloud adoption, which advocate for a deliberate and iterative approach. By first establishing efficient data ingestion and transformation pipelines using OCI services like Oracle Functions and Data Flow, the architect ensures that the core processes are sound. This minimizes the risk of propagating inefficiencies to downstream services and allows for easier integration and scaling later. This methodical approach also supports better cost management by avoiding overprovisioning or the use of suboptimal services for core tasks. It demonstrates professional diligence by focusing on building a sustainable and efficient architecture. Incorrect approaches analysis. One incorrect approach focuses solely on immediate cost reduction by using a single, less specialized service for all data processing needs. This fails to account for the potential performance bottlenecks and increased complexity that arise when a service is used outside its optimal scope. Ethically, this can lead to a misrepresentation of the solution's long-term viability and operational efficiency, potentially causing future cost overruns and performance issues for the client. It also neglects the professional responsibility to leverage appropriate tools for the job. Another incorrect approach prioritizes rapid deployment of all features without adequate process design. This can lead to a brittle architecture where data integrity and processing logic are compromised. Professionally, this demonstrates a lack of foresight and a failure to adhere to sound architectural principles, potentially resulting in significant rework and increased support costs. It also risks creating a system that is difficult to audit or secure due to poorly defined processes. A third incorrect approach involves over-engineering with highly specialized, complex services from the outset without a clear understanding of the data volume and processing requirements. While aiming for robustness, this can lead to unnecessary complexity, increased learning curves for the operations team, and potentially higher costs than a more streamlined solution. This approach fails to demonstrate practical problem solving and can be seen as a failure to apply the principle of least complexity where appropriate. Professional reasoning. Professionals should approach process optimization in cloud environments by first understanding the core requirements and then selecting services that best fit those needs, prioritizing efficiency and maintainability. A phased approach, starting with foundational elements and iterating, is generally superior to a big bang implementation. This involves continuous evaluation of performance, cost, and scalability, and a willingness to adapt the architecture as requirements evolve. Professionals must also consider the operational impact and the skills required to manage the deployed solution. Question 15. Examination of the data shows a requirement to deploy a new customer-facing application on Oracle Cloud Infrastructure, OSI. A key regulatory mandate specifies that all customer personal data must reside within the European Union. The architecture team is considering several OCI regions for deployment, with varying costs and latency characteristics. Which OCI region selection strategy best adheres to the stated regulatory mandate while also considering architectural best practices? Option A. Deploy the application in an OCI region outside the European Union to leverage lower operational costs and implement data masking techniques to obscure personal data. Option B. Deploy the application in an OCI region outside the European Union and rely on contractual agreements with OCI to ensure data residency compliance. Option C. Choose an OCI region based solely on its proximity to the development team, assuming that data processing within OCI is inherently compliant regardless of region. Option D. Select an OCI region located within the European Union that offers the most competitive pricing and lowest latency to the primary user base. The correct answer is D. Select an OCI region located within the European Union that offers the most competitive pricing and lowest latency to the primary user base. Explanation. This scenario presents a common challenge in cloud architecture, balancing performance and cost optimization while adhering to data residency requirements. The professional challenge lies in interpreting vague regulatory guidance and translating it into concrete technical decisions within the Oracle Cloud Infrastructure, OSI, environment. The architect must consider not only the technical feasibility of different OCI regions, but also the potential implications of data transfer and processing locations on compliance. The correct approach represents best professional practice because it directly addresses the core requirement of data residency by selecting an OCI region that explicitly meets the specified regulatory framework's mandates. This proactive selection minimizes the risk of non-compliance and avoids costly remediation efforts. It demonstrates a thorough understanding of the regulatory landscape and its impact on cloud deployment strategy. An incorrect approach that prioritizes cost savings without verifying data residency compliance is professionally unacceptable. It creates a significant regulatory risk, potentially leading to fines, reputational damage, and legal repercussions. Such an approach fails to uphold the architect's ethical responsibility to ensure the security and compliance of the deployed solutions. Another incorrect approach that relies on the assumption that all OCI regions offer equivalent data residency guarantees is also flawed. This demonstrates a lack of due diligence and an oversimplification of complex regulatory requirements. Regulatory frameworks often have specific stipulations about where data can be stored and processed, and these vary by region. Ignoring these nuances can lead to inadvertent noncompliance. Finally, an approach that delays the data residency decision until after deployment introduces unnecessary risk and inefficiency. This reactive stance can lead to costly re-architecting and data migration efforts if the initial deployment is found to be noncompliant. Best professional practice dictates a proactive, compliance-first design. The professional decision-making process for similar situations should involve 1. Thoroughly understanding the specific regulatory framework and its data residency requirements. 2. Identifying OCI regions that demonstrably meet these requirements. 3. Evaluating the trade-offs between compliant regions in terms of cost, performance, and service availability. 4. Documenting the rationale for the chosen region and the compliance verification process. 5. Engaging with legal and compliance teams to validate the architectural decisions. Question 16. The control framework reveals a critical performance degradation issue impacting a key Oracle Cloud Infrastructure (OSI) application. The architecture team is tasked with optimizing the application's responsiveness and throughput. Which of the following strategies represents the most effective and professionally responsible approach to address this challenge? Option A. Undertake a complete re-architecture of the application into a microservices-based design, assuming this will inherently improve performance and scalability, and deploy it across multiple OCI regions for maximum availability. Option B. Focus exclusively on front-end code refactoring and client-side performance enhancements, such as image compression and JavaScript optimization, while deferring any back-end system analysis or modifications. Option C. Conduct a thorough performance profiling and bottleneck analysis, using OCI monitoring tools and application logs to identify specific areas of inefficiency, followed by targeted optimization such as implementing caching strategies, optimizing database queries, or introducing asynchronous processing. Option D. Immediately provision additional compute instances and increase the allocated memory and CPU for existing instances to handle the perceived load, without a detailed investigation into the root cause of the performance issue. The correct answer is C. Conduct a thorough performance profiling and bottleneck analysis using OCI monitoring tools and application logs to identify specific areas of inefficiency, followed by targeted optimizations such as implementing caching strategies, optimizing database queries, or introducing asynchronous processing. Explanation. The control framework reveals a critical need to optimize the performance of a customer-facing Oracle Cloud Infrastructure (OSI) application. This scenario is professionally challenging because it requires balancing the immediate need for improved application responsiveness with the long-term implications of architectural decisions, ensuring compliance with OCI best practices and potential service level agreements, SLAs, without introducing new risks or violating security principles. The chosen optimization strategy must be cost-effective and sustainable. The correct approach represents best professional practice because it prioritizes a systematic, data-driven methodology. By first establishing baseline performance metrics, identifying specific bottlenecks through monitoring and logging, and then implementing targeted optimizations such as caching, asynchronous processing, or database query tuning, the solution directly addresses the root causes of performance degradation. This aligns with OCI's architectural best practices for performance and scalability, ensuring that changes are measurable and reversible if they negatively impact other aspects of the application. This methodical approach minimizes the risk of unintended consequences and ensures that optimizations are effective and aligned with business objectives. An incorrect approach that involves immediately scaling up compute resources without understanding the underlying performance issues is professionally unacceptable. This is because it represents a brute force solution that is often inefficient and costly, failing to address potential architectural or code-level inefficiencies. From a regulatory and ethical standpoint, it can lead to unnecessary expenditure of client or organizational funds, violating principles of fiscal responsibility, and potentially breaching contractual obligations if SLAs are not met due to the underlying issues remaining unresolved. Another incorrect approach such as implementing a complex microservices architecture without a clear business driver or sufficient understanding of the operational overhead, is also professionally flawed. While microservices can offer benefits, they introduce significant complexity in deployment, monitoring, and management. Without a strong justification and a phased implementation plan, this can lead to increased operational burden, potential security vulnerabilities due to distributed systems, and a failure to achieve the desired performance gains, thus not representing a prudent or responsible architectural decision. A third incorrect approach, focusing solely on front-end optimizations without considering back-end performance, is also professionally unsound. This creates an incomplete picture of application performance. While front-end improvements can enhance user experience, if the back-end is the bottleneck, the overall application responsiveness will remain poor. This can lead to misallocation of resources and a failure to meet performance objectives, potentially impacting customer satisfaction and business outcomes. The professional decision-making process for similar situations should involve a structured approach. 1. Understand the business context. Clearly define the performance goals and their impact on business objectives. 2. Data collection and analysis. Gather comprehensive performance metrics and logs to identify specific bottlenecks. 3. Root cause identification. Use analytical tools and expertise to pinpoint the exact reasons for performance issues. 4. Solution design. Develop targeted optimization strategies based on the identified root causes, considering OCI best practices, cost, security, and maintainability. 5. Phased implementation and testing. Implement changes incrementally, with thorough testing at each stage to validate effectiveness and prevent regressions. 6. Continuous monitoring and iteration. Establish ongoing monitoring to ensure sustained performance and identify new optimization opportunities. Question 17. The assessment process reveals that users are experiencing intermittent slowdowns when accessing a critical application hosted on Oracle Cloud infrastructure. The application's architecture includes compute instances, a load balancer, and an Oracle Autonomous Database. The current monitoring shows no obvious resource exhaustion on the compute instances. What is the most effective and compliant approach to diagnose and resolve this performance degradation? Option A. Implement a custom application-level caching layer across all application tiers without first investigating existing performance bottlenecks or database query efficiency. Option B. Immediately provision additional compute instances and scale up the autonomous database to handle potential increased load, assuming the issue is simply insufficient capacity. Option C. Focus solely on increasing the network bandwidth between the application tiers and the autonomous database, assuming network latency is the primary cause of the slowdown. Option D. Analyze detailed performance metrics from the autonomous database, including query execution times, connection pooling, and wait events, in conjunction with load balancer connection statistics and application logs to identify specific areas of contention or inefficiency. The correct answer is D. Analyze detailed performance metrics from the autonomous database, including query execution times, connection pooling, and wait events, in conjunction with load balancer connection statistics and application logs to identify specific areas of contention or inefficiency. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture where performance bottlenecks are identified, impacting user experience and potentially business operations. The professional challenge lies in accurately diagnosing the root cause and implementing an effective, compliant solution without introducing new risks or violating service-level agreements, SLAs, or Oracle Cloud Infrastructure, OCI best practices. The need for a systematic, data-driven approach is paramount. Correct approach analysis. The correct approach involves a methodical investigation using OCI's built-in monitoring and logging tools. This aligns with OCI's architectural principles of observability and proactive management. By analyzing metrics such as CPU utilization, memory usage, network I/O, and database query performance, an architect can pinpoint the specific component or service causing the degradation. This data-driven approach ensures that solutions are targeted and effective, minimizing disruption and adhering to performance expectations defined in SLAs. It also supports compliance with OCI's recommended operational best practices for resource optimization and performance tuning. Incorrect approach is analysis. One incorrect approach is to immediately scale up all compute resources without proper diagnosis. This is a brute force method that can lead to unnecessary costs and may not address the actual bottleneck if it lies elsewhere, e.g., network latency, database contention, or application logic. From a regulatory and ethical standpoint, this approach fails to demonstrate due diligence in resource management and could violate cost optimization principles often implicitly or explicitly expected in cloud governance frameworks. It also risks over-provisioning, which can be seen as inefficient use of cloud resources. Another incorrect approach is to implement a complex, custom caching solution without first understanding the application's data access patterns and the existing caching mechanisms. This introduces significant development overhead and potential for introducing new bugs or performance issues. Ethically, it represents a failure to leverage existing, well-tested OCI services and best practices, potentially leading to a less secure and less maintainable solution. It also bypasses the opportunity to optimize existing configurations before resorting to custom development. A third incorrect approach is to assume the issue is solely related to network latency and to immediately implement a content delivery network, CDN, without verifying network metrics or application-specific network dependencies. While a CDN can improve performance for certain types of content, it's not a universal solution for all performance issues. This approach could be ineffective if the bottleneck is elsewhere, leading to wasted effort and resources. It also fails to adhere to a structured problem-solving methodology, which is a cornerstone of professional cloud architecture. Professional reasoning. Professionals should adopt a structured iterative approach to performance optimization. This involves 1. Monitoring and data collection. Continuously gather performance metrics from OCI services. 2. Root cause analysis. Analyze collected data to identify the specific component or service causing the bottleneck. 3. Hypothesis and solution design. Formulate hypotheses about the cause and design targeted solutions. 4. Implementation and testing. Implement the chosen solution and rigorously test its impact. 5. Validation and iteration. Validate that the performance issue is resolved and iterate if necessary. This systematic process ensures that solutions are effective, cost-efficient, and compliant with OCI best practices and any relevant governance policies. Question 18. Market research demonstrates that organizations are increasingly adopting DevOps practices for faster service delivery on Oracle Cloud infrastructure. An architect is tasked with optimizing the CI/CD pipeline for a new application that will process sensitive customer data. The primary goal is to accelerate the deployment frequency, while ensuring that all security and regulatory compliance requirements are met without introducing new risks. What approach best balances these competing objectives? Option A. Integrate automated security scanning, compliance checks, and access control validation directly into the CI/CD pipeline, ensuring these are prerequisites for deployment. Option B. Delegate all security and compliance responsibilities to a separate, dedicated team that operates independently of the development and deployment teams, with minimal integration into the CI/CD workflow. Option C. Focus solely on accelerating the deployment process and schedule separate, manual security and compliance audits after the application is live in production. Option D. Implement security and compliance measures only when a critical security vulnerability is detected or a regulatory audit is imminent, treating them as reactive incident response activities. The correct answer is A. Integrate automated security scanning, compliance checks, and access control validation directly into the CI/CD pipeline, ensuring these are prerequisites for deployment. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing the need for rapid deployment and feature iteration with the imperative to maintain robust security and compliance. The pressure to deliver new services quickly can lead to shortcuts that inadvertently expose sensitive data or violate regulatory requirements. The architect must navigate competing priorities, ensuring that process optimization does not compromise the integrity and security of the cloud environment, especially when dealing with data subject to specific regulations. Correct approach analysis. The correct approach emphasizes a proactive and integrated strategy for security and compliance within the CI/CD pipeline. By embedding security checks, automated compliance validation, and access control reviews directly into the development and deployment workflows, the organization ensures that these critical aspects are addressed from the outset. This aligns with the principle of security by design and compliance by design, which are fundamental to responsible cloud adoption. This approach minimizes the risk of introducing vulnerabilities or compliance gaps during rapid iteration, thereby safeguarding data and maintaining regulatory adherence. It fosters a culture of shared responsibility for security and compliance across development and operations teams. Incorrect approaches analysis. One incorrect approach involves relying solely on post-deployment audits for security and compliance. This is reactive and inefficient. Regulatory frameworks often mandate preventative measures and continuous monitoring, not just retrospective checks. Such an approach significantly increases the risk of breaches or non-compliance going undetected until after a potential incident, leading to severe penalties, reputational damage, and loss of customer trust. Another incorrect approach is to treat security and compliance as separate, manual processes that are initiated only when a new service is nearing production. This creates bottlenecks and disconnects between development and security/compliance teams. It also fails to leverage the automation capabilities of cloud platforms and CI/CD tools, leading to delays and increased human error. Regulatory requirements often demand that security and compliance be integral to the entire lifecycle, not an afterthought. A third incorrect approach is to prioritize speed of deployment above all else, assuming that security and compliance can be addressed later or are the responsibility of a separate team without proper integration. This demonstrates a fundamental misunderstanding of the shared responsibility model in cloud environments and the pervasive nature of security and compliance obligations. It can lead to the deployment of services that are inherently insecure or non-compliant, exposing the organization to significant legal and financial risks. Professional reasoning. Professionals should adopt a risk-based approach, integrating security and compliance considerations into every stage of the cloud architecture lifecycle. This involves 1. Understanding the data's sensitivity and applicable regulations. 2. Designing for security and compliance from the initial architecture phase. 3. Automating security and compliance checks within CI/CD pipelines. 4. Implementing robust access control and identity management. 5. Establishing continuous monitoring and auditing mechanisms. 6. Fostering collaboration between development, security, and compliance teams. 7. Regularly reviewing and updating security and compliance postures based on evolving threats and regulations. This systematic and integrated approach ensures that process optimization enhances, rather than compromises, the security and compliance posture of the Oracle Cloud Infrastructure environment. Question 19. Compliance review shows that a significant portion of the organization's Oracle Cloud Infrastructure spend is attributed to resources that have been provisioned over the last 2 years. While these resources support various business functions, there is a lack of clear visibility into their ongoing utilization and the direct business value they provide, leading to concerns about potential cost inefficiencies. As the OCI architect, what is the most appropriate approach to address this situation? Option A. Mandate the immediate termination of all OCI resources that have been active for more than 18 months, regardless of their current usage or business criticality. Option B. Implement a comprehensive resource utilization and cost analysis to identify underutilized or redundant OCI services, and then propose targeted optimization strategies based on data-driven insights. Option C. Focus exclusively on migrating all existing workloads to the cheapest available OCI compute and storage services to reduce overall expenditure. Option D. Continue to provision new OCI services as requested by business units, assuming that the current spend reflects necessary operational requirements. The correct answer is B. Implement a comprehensive resource utilization and cost analysis to identify underutilized or redundant OCI services, and then propose targeted optimization strategies based on data-driven insights. Explanation. Scenario analysis. This scenario presents a common challenge in cloud environments where the rapid adoption of services can outpace established governance and cost management practices. The challenge lies in balancing the agility and innovation offered by OCI services with the need for financial accountability and adherence to organizational policies. Without a clear process for evaluating the ongoing value and necessity of deployed resources, organizations risk incurring unnecessary expenditure, impacting overall profitability and potentially diverting funds from strategic initiatives. The architect must navigate the technical feasibility of optimization with the business imperative of cost efficiency. Correct approach analysis. The correct approach involves a systematic review of resource utilization and cost allocation. This aligns with best practices for cloud financial management, often referred to as FinOps, by identifying underutilized or redundant resources, and by analyzing cost drivers, an architect can propose targeted optimizations. This might include right-sizing instances, leveraging reserved instances or savings plans for predictable workloads, implementing automated shutdown policies for non-production environments, or exploring more cost-effective OCI services that meet the same functional requirements. This proactive and data-driven approach ensures that OCI investments are aligned with business value and operational needs, demonstrating responsible stewardship of company resources. This is ethically sound as it prevents wasteful spending and ensures resources are allocated effectively. Incorrect approach is analysis. Continuing to provision new services without a review of existing, potentially underutilized resources is a failure in due diligence and responsible resource management. This approach ignores the principle of maximizing value from existing investments and can lead to significant cost overruns. Ethically, it represents a disregard for organizational financial health. Implementing a blanket policy to terminate all resources older than a certain arbitrary period, without considering their actual usage or business criticality, is a reckless and potentially damaging approach. This could disrupt critical business operations, lead to data loss, and negatively impact customer service. It fails to apply professional judgment and a nuanced understanding of business requirements, leading to operational and reputational damage. Focusing solely on the lowest cost OCI service for every new deployment, without a thorough assessment of its suitability for the intended workload, performance requirements, and long-term operational implications, is also problematic. While cost is a factor, it should not be the sole determinant. This can lead to performance bottlenecks, increased operational overhead, and ultimately higher total cost of ownership if the chosen service proves inadequate. This approach prioritizes a single metric over a holistic understanding of technical and business needs, which is professionally unsound. Professional reasoning. Professionals should adopt a continuous improvement mindset for cloud resource management. This involves establishing clear governance policies, implementing robust monitoring and alerting for resource utilization and costs, and fostering a culture of cost awareness across technical teams. When faced with potential cost inefficiencies, the decision-making process should involve 1. Data gathering. Collect comprehensive data on resource usage, performance metrics, and associated costs. 2. Analysis. Analyze the gathered data to identify patterns, anomalies, and areas for improvement. 3. Solution design. Propose specific actionable optimization strategies that balance cost, performance, and business requirements. 4. Stakeholder communication. Engage with business stakeholders to explain the proposed changes, their impact, and the expected benefits. 5. Implementation and monitoring. Execute the chosen optimizations and continuously monitor their effectiveness. Question 20. The efficiency study reveals that a critical Oracle Cloud Infrastructure (OCI) service, responsible for processing sensitive customer data, is experiencing intermittent performance degradation, impacting downstream applications and potentially violating service-level agreements (SLAs). Which of the following actions represents the most professional and effective approach to diagnose and resolve this issue? Option A. Revert all recent configuration changes made to the OCI environment without further investigation. Option B. Immediately scale up the compute instances associated with the service and monitor for improvements. Option C. Systematically analyze OCI monitoring and logging data to identify performance bottlenecks and correlate with recent environment changes before proposing a solution. Option D. Engage the application development team to rewrite the service's code, assuming the issue is application level, without initial infrastructure diagnostics. The correct answer is B. Immediately scale up the compute instances associated with the service and monitor for improvements. Explanation. The efficiency study reveals that a critical Oracle Cloud Infrastructure (OCI) service, responsible for processing sensitive customer data, is experiencing intermittent performance degradation. This degradation is impacting downstream applications and potentially violating service-level agreements (SLAs) with clients. Challenge lies in identifying the root cause and implementing a solution without compromising data integrity, security, or incurring excessive downtime, all while adhering to OCI's best practices and the implicit regulatory expectations around data availability and processing. The correct approach involves a systematic and phased investigation, prioritizing minimal disruption. This includes leveraging OCI's monitoring and logging tools, e.g., OCI monitoring, OCI logging, to gather detailed performance metrics and error logs. The next step is to correlate these findings with recent changes in the OCI environment, such as deployments, configuration updates, or scaling events. Based on this analysis, a targeted troubleshooting plan can be developed, potentially involving isolating the problematic component, testing configuration adjustments in a non-production environment, and then applying changes during a planned maintenance window. This methodical approach ensures that any intervention is data-driven, minimizes risk, and aligns with the principle of least privilege and operational resilience, which are foundational to maintaining trust and compliance in cloud environments. An incorrect approach would be to immediately scale up resources without a clear understanding of the bottleneck. This could mask the underlying issue, lead to unnecessary costs, and potentially exacerbate performance problems if the bottleneck is not resource-related, but rather a configuration or application logic issue. This approach fails to demonstrate due diligence and a structured problem-solving methodology. Another incorrect approach is to revert recent changes without proper analysis. While seemingly a quick fix, it bypasses the critical step of understanding why the change caused an issue. This can lead to recurring problems and a lack of learning from operational incidents, which is a failure in continuous improvement and robust operational management. Finally, a failure to document the troubleshooting process and the implemented solution is also professionally unacceptable. This hinders knowledge sharing, makes future problem resolution more difficult, and can be a compliance issue if audit trails are required. It demonstrates a lack of professional rigor and accountability. The professional reasoning process for such a scenario should involve 1. Acknowledging the impact and urgency. 2. Prioritizing data integrity and security. 3. Utilizing OCI's native diagnostic and monitoring tools. 4. Formulating hypotheses based on observed data. 5. Testing solutions in a controlled manner. 6. Implementing changes with minimal disruption and proper rollback plans. 7. Thoroughly documenting all actions and outcomes.